Thank you to be here at the last session. So yes, the title is a bit long. I hope that the talk will be interesting enough for you. Just before starting, how many of you have ever used a Web 3.0 application or service? One, fine. And how many of you do know about transclusions? One, fine. Two, perhaps. Okay, and Folksonomies? One, okay, fine. So let's see. Sorry. Okay. So we are told that we are at the dawn of a new era in internet applications, of distributed applications, decentralized, web, blockchain, and so on. This is a nice picture from this blog. And on each column on the right, you will find the Web 3.0 application, and on the left, maybe some 2.0 or older applications. So you see an amazing number of things going on. But the main point is, as happened with Web 2.0 and Web 1.0, actually Web 3.0 is not about new features. It's not about something new. It's the third attempt to fix the Web 1.0 problems, because before going again on the decentralization and other stuff, we had the Web 2.0 that was able to solve the problems of the Web 1.0. Actually, they told us that it was about new features, new things, and the funny thing is that when the Web 1.0 came out, they were telling us that the semantic web will come to us with the Web 2.0. Then when the Web 2.0 application came out, they told that maybe the Web 3.0. And here we are again. So funny enough, the story of the web, as we know from the Web 1.0, was always a way of trying to fix problems rather than adding features. I know that is a very opinionated point of view on the web, but have a bit of patience and follow me on these things. So, why? Because even today, we still struggle with what I call the 5 paradoxes of digital content. And we haven't solved them yet. The first paradox is that content is available everywhere nowadays. You can access things from wherever you are, with which kind of tool you want, your computer, your laptop, your smartphone, and so on, but is yet stored in very few places. The 70% of the internet traffic in 2018 was routed through Google and Facebook. And a vast amount of content is stored inside Google, Facebook, and other monopolies nowadays. So it's very easy to switch them off. We are fooled by the idea that we can access Facebook on the run, on the train, maybe on the airplane in some cases, but they're stored in very few places. This is the problem we have nowadays with centralized data silos. When it all started, the web was meant to be, let's say, decentralized at least, but how we built actually in the Web 2.0 revolution and so on was moved towards centralization. That's the Web 3.0 tries to, at least says that it tries to solve this kind of problem, and we need to see if it's true or not. The second paradox is that content is very easy to find if it stays in the same place. And that's the problem of how the URI protocol was implemented for the World Wide Web, and how the URLs were actually built in a way that were server addressed. And again, we are trying now with the Web 3.0 to solve this kind of problem with content-addressed URLs. And we will talk about this later. But the key point is that we spend an incredible amount of energies to keep track of where things are. And that's why we needed the search engines. The average life of a web page on the internet, these are stats from the Internet Archive, is around 30 days. Things moves a lot. And so we need thousands of spiders out there going on, trying to search, catalog, and so on. And that's bring us to the third paradox. It's easy to search. Yes, we need search engines, otherwise we are doomed with the broken links, the 404 error. I mean, when you encounter the first time the 404, you lost your internet virginity in some ways. And yes, we need the search engines. It's easy to search for things, but it's still very hard to catalog them. And if we spend energies in cataloging things, I mean human cataloging things, most of the time the effort is lost. And the fourth paradox is that by its own nature, digital content is very easy to duplicate, to clone. And you can tell the difference between the original and the copy. And that has been seen as a problem so far, because all the efforts that we spent towards DRM and rights and so on is that because it's still very costly to attribute things. We can easily duplicate. We struggle a lot with protection of content. We spend very few energies in trying to solve the problem of attribution. And the fifth paradox, the most problematic one, is that for the very first time in whole human history, we are encoding both the media and the tool to read it. So far, with books, with pictures, we encoded the media. You have to learn how to read the book. You have to understand the language, the way that those symbols on the page are written. But once you learn how to learn, you're able to read the book with your own very eyes. But nowadays, we have a very big amount of knowledge of content that is stored in computers in a way that not only is stored in a format, but the tools that we need to read those things are encoded by themselves. This is the hardware and software obsolescence problem. And the industry is not so young. We already have problems in this way. We have problems with software the document formats. We have problem with storage formats. We have problem with computers. We have start losing things from the 60s, from the 70s, from the 80s. And now with the cloud, we are fooled by the idea that if it's on the cloud, it will stay there forever, like a miracle. But we still have to solve this problem. And nowadays, that in some regions, in some countries where, think about yourself, probably now the most part of your things are digitalized first, are digital first. Maybe you have some physical copy. 10 years ago, 20 years ago, you had only physical things. I had computers since I think almost 30 years ago, but that's not a problem. So I had very few things on the computer at that time. Nowadays we have tons of things. We have an incredible amount of things, and we pay no attention to this problem. So, sorry, just a second, the animation. Okay, so why talk about transclusions? What are transclusions? Maybe some of you, if you are a JavaScript programmer, I have used transclusions as a term of embedding things inside a DOM document. Actually, transclusion have a very long story. And why we need to talk about transclusion? We need to talk about how and why the web was invented, really. And the story goes back very long time ago. So I want to introduce you in this talk to two men that, in my opinion, shaped the way the web should have been, but for several reasons, we were not able to fulfill their ideas and promises. So the first man is Vannevar Bosch. I don't know if you ever heard of him. Was an amazing scientist, has been the director of the Research and Development Office during the Second World War in the US, coordinating the work of thousands of scientists during the war, but was also the inventor of an incredible idea for the time. In the 30s, he recognized there was a problem. In the 30s of the 20th century, not in so almost 1 century ago. So he says, yes, we are overwhelmed by the information in the scientific world. So we are struggling to keep up with information. And this kind of problem should be solved. Otherwise, we will not be able to make any progress. That was almost 1 century ago. And this is a comment extracted from an article published later in the 45, but he recognized that there was already an overload of information. And imagine a way of dealing with this. This is their first desktop computer, was really a desktop. Was a mental experiment, was a desktop. And in the 30s, we had analog computing. We didn't have digital computers. Computers were based on optoelectronics things. And imagine these mimics as a way of solving the problem of of information overhead. And it's a long story. I will show you a very small video done for the 15th anniversary of the mimics that can explain better than words. The text is read from the book of the...
The owner of the mimics, let us say, is interested in the properties of the bow and arrow. He has done possibly pertinent books and articles in his mimics. First he runs through an encyclopedia, finds an interesting but sketchy article, and leaves it projected. Next, in a history, he finds another pertinent item and ties the two together. Thus he goes, building a trail of many items. Occasionally, he inserts a comment of his own, either linking it into the main trail or joining it by a side trail to a particular item. His trails do not fade. Several years later, his talk with a friend turns to the Turkish bow. In fact, he has a trail on it. It is an interesting trail, pertinent to the discussion. So he sets a reproducer in action, photographs the whole trail out, and passes it to his friend for insertion in his own mimics.
So, in the 30s, Bosch imagined a desktop based on microfilms and printing techniques and optoelectronics that was able to establish trails, so links between pages in microfilms, and preserve them and being able to share those links among other scientists. And he did this because he believed that the way that mind works, that's the title of the article, as we may think, is an associative way. So our mind works by associations. And the big problem that we have with knowledge is that associations are inside our minds. And with a tool like this, he hoped to be able to save those links that we made in our mind in actual trails, printed on microfilms. Of course, the rumors is that because you have selectors and levers and things spinning inside the desktop. So, MEMEX trails were supposed to print and preserve for future generation the associative thinking of scientists. And this was imagined in the 30s of the past century. That's where and when all the hypertext, hypermedia things started. And the work of this, and instead we have now the Web 2.0 with all the clashing problems that we had with this. Things, links going through servers and services and not being able to be preserved and shared properly. And the property of those links as well is an issue. And I want to introduce you to another guy. I don't know, again, if you know about Ted Nelson. Ted Nelson is still alive, and it's a genius and a mad scientists at the same time. And is the inventor of the project Xanadu. And in the slides, you will find a link to a very interesting article of Wired in 1995 called The Course of Xanadu. In this article, it defined the Xanadu project the biggest and costlier vaporware of the time. Ted Nelson worked on Xanadus for almost 30 years. And he was able to convince very big company, the last one was Autodesk, to invest in this idea, and he never succeeded to create one. But in any case, the idea that Ted created for Xanadu system were actually the foundation of the internet, the Web 1.0. Tim Berners-Lee knew very well the work of Nelson, and knew very well that was not able to implement all the features that Nelson envisioned. And to give you a glimpse of what was hypermedia, the term was coined by Ted Nelson actually, before hypertext. I will show you two quick videos. Look at the screen. This is Windows XP, so you can guess the age of the video.
Hi, I'm Ted Nelson. I want to talk about the structure of computer documents. Now, most people think they know what electronic documents are because they've seen them. They've seen Microsoft Word, they've seen Adobe Acrobat. And what are computer documents like? They imitate paper. Well, when I was learning to write in my teens, it seemed to me that paper was a prison. 4 walls, right? And the ideas were constantly trying to escape. What is a parenthesis but an idea trying to escape? What is a footnote but an idea that jumped off the cliff? Because paper enforces single sequence and there's no room for digression, it imposes a particular kind of order in the very nature of the structure. When I saw the computer, I said, at last we can escape from the prison of paper. And that was what my whole hypertext idea was about in 1960 and since.
So I can explain transclusion in several ways, but I think that the most effective way is to look at the second video here. This was a demo of a Xanadu system, the latest version of Xanadu system that wasn't able to go into production. Then at some point, then the World Web 1.0 came out and everything was stopped on the Xanadu system. But that's what the transclusion is in the idea of Ted Nelson.
Here we are in Xanadu space. This is a 3-dimensional setup, and we see a document of 11 different pages. Now, I'm going to fly through it in 3D, and you can see the various different connections between the documents. There are only 27, I think, connections between these 11 pages, but you can see how complex they get because we are allowing overlap and interconnection of in any quantity, potentially hundreds or millions of links. How do we keep them sorted out? Aha! That is the nice touch here. In the front, we have 2 pages. The current page with the large type and its companion page with the smaller type. And this connection is a transclusion. That is the same content in 2 places. It is not a link. It is not represented by link structures. It is differently found. So here we have, in the beginning God created the heaven and earth, in a quotation, and here in the companion document is the origin in the King James Bible. Now, I just made the companion document, the companion page, the current page. We'll go back to the current page, to this current page, and step through to various documents, and we see, as we step through the connections on this page, that the other documents swarf into position. It's swoop plus morph. They swarf into position, and the connections become exactly readable. So one connection at a time, we can follow what the connections actually mean, even though we are in a huge conglomerate of many different connections. So that's it. That is Xanadu.
Okay, so from an usability point of view, it's a nightmare. So let's imagine to explain to your mother how to use Xanadu. But the key point here is not usability, was the way that things were connected together. So Tim Berners-Lee with the Web 1.0 was very aware of the fact that the kind of links that were trying to build inside the HTML 1.0 were just the fractions of the links imagined by Theodor Nelson. And actually, all those things were based on tumblers. That were an idea developed in the 60s based on transfinite numbers. And you can see here, if you try to close your eyes a bit, for example, the node is something very similar to what we know now as TCP/IP, but with the difference that it can address an infinite number of nodes. And actually, each number is not a number, it's a number, which was a very clever and compact notation to express very, very long numbers, and it represents a hierarchy. And so they tried to, of course, failing at this because it was too complex and is still too complex in some respect, to map the idea of, let's say, a node of the system. Then the user, they are separated by the zero. The zero defines what's next, so the user. And again, the user is modeled in a way you can express relationship between users. So you may have a company and then a hierarchy with the employees and other things and so on. And then you have a document with version revision. Welcome to the Git of the 60s, because actually here you have, now in Git we have hashes and we have Merkle trees, but the idea is roughly the same. So you have a hierarchy of versions you can navigate through. Of course, there was no idea of hashes at that time, and they use numbers, but again, you have a hierarchy there with the revision of the document. And then you can access a fragment of the document, the exact 50th character in the document as well, if it's prefixed by 1. And that's interesting, aside from the content, you can also access the links built or used inside the content. So separated between. So they are not in the same array of bytes, they are on a separate array. And that's another interesting thing we need to... So the last one is the link number 15 belonging to document 75 version 2. And you can have a list of links and so on. And in this way, being each segment a hierarchy, you can express links that can be preserved across revisions. That's a complex idea. We don't have time to express it, but I can define an interval. So there is a mathematic around behind this. So you have some additions, subtractions. You can express ranges in a way that being transfinite numbers, you can express a range no matter how complex the hierarchy can be inside. So you can start addressing the first character of the document 75 and the 10th character as a range. And if you insert characters in several revisions, you can still use the same range, the same link to extract an array of bytes in the different versions of the file. That was amazing, and I think it's still amazing. They were not able to make it work properly, of course, for a lot of reasons, but that is the foundation of the problem and almost the solution that we are still searching for. So Xanadu's transclusions were supposed to be bidirectional and persistent links between portions of content and authors. So the author is inside the link. It's not a separate thing. The attribution problem was built inside the protocol. It's not an afterthought like we have today. But the point was to make those links available and persistent for other people and make those things available on a public network. So everybody could access them and could have the right attribution of content. And in the mind of, so let's imagine the 70s, talking about micropayment based on how much you were linking, embedding content was a crazy idea, and it still is somehow. So, and instead we have the Web 1.0 with relative links and, yes, fragments, no idea about attribution, no idea about being able to duplicate content properly, and so on. So, this is a quote from one of the pioneers of the internet, and it's a very recent article. It says, the original idea was to make the internet just super bare bones. So the initial internet had no representation of people. There was no membership concept, no identity concept. There was no sense of authentication. We spent a lot of years trying to, and we are still trying to establish this. Think about fake news, for example. That's a recent problem, of a very old one. There was certainly no implementation of e-commerce solution. And there was nothing. It was just very, very raw. And in that spirit of keeping everything as minimal as possible, the web protocol committed the primal sin of not having backlinks. We have just monodirectional links. And the article is very interesting. I advise you to read it. But so the problem of having just monodirectional links is still a sin, is still a problem. But now we have content-addressed URLs. I don't know how many of you has seen this. So this is content addressed. It means that you don't know where actually this content is, but thanks to this protocol IPFS and to a peer-to-peer network, distributed network in this sense, and a routing protocol, you are able to ask bits of this content. This is the hash representing the content of the document you are searching for. So you can ask pieces of this content across the peer-to-peer network like you have done, you should have done in Napster so many years ago with MP3. And you can, if a server has the same content, is no problem at all. You can duplicate the content on many servers as you want, and they can all serve them in a peer-to-peer way. That's IPFS. That solves a part of the problem. That solves the first paradox I told you about. And of course, this is not the only solution. We have another content-addressed way of expressing the same thing, which is that project that has another feature that IPFS doesn't have. So they have complementary features. We're still struggling to understand how to merge those features together. For example, that project was born for university and large data sets, so you can express also fragments. You can ask for this content, but just a fragment of this. Or you can just for a revision of this. In IPFS, you can't. And that's the that project. But that doesn't solve the problem of links, because I can explain you with a very simple use case. So imagine that you have two pages, page A and page B. And you want to place a link in page A pointing at page B. And you want to put a link in page B pointing to page A. So it's trivial to do this in HTML. It's a relative URL. Who cares? In a content-addressed world, instead, you have a problem. You have an egg and chicken problem, because if you want to use a content-addressed URL inside A pointing at B, you have first to compute the hash of B. But if you want to put the link in B pointing at A, you should have first the hash of A. So how you can solve this problem? You can't. Okay, so if you try to convert your blog, as I've done, in IPFS, and you just want to have the main page with all your articles, then you can click and go to the article. But if you want to implement the back to the main page, you got a problem. Yes, in IPFS you have IPNS that partially solves the problem. It's very slow, problematic, and so on. That as another way of solving the same problem, but again, that's a big problem with links. And guess what? Yes, there is a technology that is a combination of cryptography, peer-to-peer network, and the game theory. Guess what it is? Blockchain. Okay, so nowadays everybody wants to store things in the blockchain. Okay, so every new company say, we can store an incredible amount of information in the blockchain. Actually, you can't. I don't know if you have tried to look inside a block in the Bitcoin or the Ethereum network. You can store very small things, and they have a cost. Because you have to, in Bitcoin, store the information in a transaction as a transaction that can be redeemed. So it has a cost for the miner to mine it, okay? And you have to put a reward in order to ask the miner to compute it. And even in Ethereum, the cost of the storage is incredibly high unless you store information inside the logs, but the logs are not blockchain like the normal content. So yes, we have Bitcoin, which is, let's say, tested at the moment. So the history of Bitcoin and the way its evolution is managed is one of the most stable at the moment blockchain available. It's public and permissionless, so it's a good candidate to store things that you want to make accessible by everybody. And actually, if you look inside some of the blocks already present in Bitcoin, you may find some example of attempt to store links to external storage that are not accessible anymore, unfortunately. So they are all 404 problems, but they tried. And I think that this could be one of the solutions of the egg and chicken problem. So yes, you can store links probably. We need to imagine, this talk is not about solution, it's about questions, the right question to be asked. So yes, we have to imagine a way of storing things inside the blockchain, pointing to external storage that may not disappear. IPFS may be a good candidate, that project may be another good candidate, but we need to think forward. The same goes for Ethereum. Ethereum has been a more problematic history so far, let's say this way, but it's again a good candidate. But the real question is, are we building a Web 3.0 for future generations? Because the paradox of the blockchain so far is that there are an incredible amount of companies trying to build their own blockchain to allow a public or always available network of nodes that disappear in 6 months. So if we want to use blockchain, we need to ensure that those chains of blocks are going to stay for a reasonable amount of time. But this is only about the how. So how links should be done, where links should be stored, but why? And I think folksonomies, which is a strange term, but it's actually very interesting, is a way of expressing that links has meanings. Links mean something. That was the original idea of Vannevar Bosch. That was the idea also of Theodor Nelson, not so semantic as Bosch, but again. So we need to establish meaning on links. And guess who is the biggest repository of folksonomies nowadays? You have an idea? Okay, it's this one. When you enter an hashtag, actually, you are building a classification, a human-made classification of a content. And can you imagine Twitter without hashtags? Will be as a very narrow Facebook. So with Twitter, it's not about 140 characters, is not about nowadays about it. But this was about how easy it was to publish content. But the real power of Twitter is about hashtags. And they are called this way because they are tags. And since they are entered by humans, you can search in Twitter for an hashtag and follow interesting things, meaningful things for you. So the biggest folksonomy that we have built so far is inside a monopoly, is inside the data silos. And even worse, is inside the text. So it's not a link anymore. And I call this the Bermuda Triangle of content. So every day, millions of things, millions of content on the internet are lost inside this triangle. We are struggling with folksonomies. We are struggling with ontologies. Yes, we have still ontologies around. And they are mostly done by experts. And it's good. When you browse inside your Spotify account, you're actually browsing an ontology. There are people that insert the artist, the name of the album. So they are classifying manually the content. And are building an ontology, very small one. You have the album, the artist, the song. They have relationship within them. You may have the producer and so on. And we can also have more complex ontologies, but again, they are hidden inside places where you can't access them easily. Okay? And then we have the Holy Grail at the moment, which is machine learning classification. So we have thousands of millions of spiders collecting information, feeding gigantic machine learning system inside Google to make sense of what we are doing every day. Most of the time, they guess it right. But when they don't guess it, that's a problem. And we still don't have a solution for this, a real solution for this. And the problem, again, is rooted to this. Is anybody of you able to guess what this is? Almost right. This is SGML. SGML was invented around in the 70s, mostly, and is the grandfather of XML. Is the way that we imagined in the 70s how to tag, classify text in a semantic way. And that's the problem. So that was a solution, of course, at the time. So imagine the task you were asked to solve. So you are to build manuals for the aerospatial industry, for example, that are made of thousands of pages. And you have the full instruction for making the airplane, maintain the airplane, and fly the airplane. And you have to provide those manuals in several languages. And you have to be sure that when you translate a term, something, it's aligned. So they invented this thing to embed inside the text tags that were semantic. They were able to classify in a semantic way the content. And in this way, we were able to parse this SGML, which was quite a nightmare in respect of XML. XML is the simplified version of SGML, but was parsable both from a human point of view and from a machine point of view. But the problem is that embedding, linking semantics inside the text made the text more cumbersome. Every time you wanted to print the text, you should read the semantic and apply a style sheet. It sounds you familiar? Okay. The revolutionary idea of Nelson was to completely separate the content from the links. And the links can express also tags because they are ranges. So let's imagine to see this text, which is actually from Lex, and it's a Lex editor, so here you have a definition of bungler, okay? So with a bunch of things. So let's imagine to have the plain text and having a second document made of links expressing ranges pointing to the right text. And in this way, you can create several layers without need to translate again and again the same text. And if you make a change on the original text, all the layers can keep track of it. So it's more easy to explain than to implement these kind of things. But you can guess. When you do a merge in Git, actually you are doing such a very similar thing. Okay, we are almost done. So I just want to finish with this thing. Have you ever heard of the 4 Ws of journalism, for example? Actually, it's a very ancient way of classifying things. Nowadays, it's used mostly in Anglo-Saxon journalism. So there is an old saying that ask a journalist when he writes an article to at least respond to all those things. So telling the article who is the article about, what is the article about, where happened the fact that you were describing, when happened, and sometimes you also ask it to explain how it happened. And if you fulfill all those things, you are writing a good article. Actually, this classification is quite old. It's rooted to the rhetoric, to the rhetor of the Latin age. And it works. It works perfectly well to help humans find things or understand things. So if you think about Twitter, you have the who with the at. You have the what with the hash. You can search for who or what. Yes, you can search for where nowadays because we have Google Maps. So you can enter coordinates on all over the world. It's more tricky if you want to enter an area, but we are almost there. And then the when is the big problem. We have very few things that we can search for when. But it's not hard for a human to classify things in this way, and it's not hard for a human to find things in this way. But it's not worth of doing this if you are pointing to things that disappear. It's an endless work. You need to have stable URLs. You have to be able to express links that last for a sufficient amount of time. So I just want to finish this talk with another quote from Bosch. It says that the human mind operates by association. With one item in its grasp, it snaps instantaneously to the next that is suggested by the association of thoughts, in accordance with some intricate web of trails carried by the cells of the brain. One cannot hope thus to equal the speed and flexibility with which the mind follows an associated trail, but it should be possible to beat the mind decisively in regard to the permanence and clarity of items resurrected from storage. And that's what my talk is about. Thank you.
Anyone has questions? Coming.
In the triangle of ontologies, folksonomies, and machine learning, but I think ontologies and folksonomies, they move, they are not static. But it could work to develop a kind of taxonomy, more like biology arranged the things, that it could be, even if it moves, will be always connected, or how it's the difference between a big file, like a movie, or a text?
So the point, from a terminology point of view, folksonomies are connected to taxonomies, okay? So actually they are informal way of classifying chunks of things, okay, made by humans in a social environment, okay? So yes, ontologies are a bit more structured. Usually we talk about ontologies when we define the domain knowledge of a specific kind of domain. So are made by expert, and yes, there is always the problem that ontologies are meant to be immutable, but actually they aren't. So there is a permanent struggle between taxonomies and ontologies at the moment. So the real problem is that they are hidden. So it's hard to preserve them at the moment, the ontologies. So they are hidden inside systems, they are hidden, they are not done in a way that can be easily accessible. So they suffer of the same problem of taxonomies and folksonomies in data silos. It's off.
Thanks for the talk. I discovered a lot of interesting stuff I had to check out, but sometimes you jumped from one thing to another without missing a lot of connection. For example, you talked about this problem of mutual links, and then you went to blockchain, but if I remember correctly, blockchain is always unidirectional.
Okay, sorry, you're right. I have not so much time, but the point is that, okay, you need an external system. So you can't express everything inside the same system. So if you build the web with links and you want to go content at restaurant on this new kind of web, you can't store the links inside the same system. So blockchain is a place external from this kind of things where you can store the tuples, so the connection between two addresses. You can take them, place inside the block, and then you can search and retrieve them. So it's a sort of side storage in order to be able to express things that you can't express inside a content-addressed world. Okay.
Any other questions? I guess no. So thanks for the interesting talk. And yeah, we have the beer time, and if you have more questions, of course you can come ask.
Thank you very much.